We have this unit circle, center at 0, 0, and with a length of 1. Okay, so that's a unique circle. So only this one. Okay, there's no other ways to sketch it. Center at 0, 0, radius of 1 is already located and it's not going to change. So unit circle is only with one type and it's looking like this. And then we talk about all these angle lines. Okay, all these angle lines. All these angle lines start from 0, 0 and also the positive horizontal position and go anti-clockwise to form an angle with the positive side of the x-axis. For example, that's a 30-degree angle. This is called the angle line. Okay, this is called the angle line. Okay, what's the good thing is we can see there's an intersection. Okay, I'll use red color to can't see red really. I'll use this green color here to show the intersection. Okay, there is an intersection between the unit circle and the 30 degrees angle line. These coordinates will be unique. Okay, even though you don't know what is the intersection, because you don't know how to calculate yet. But just let you know, for year 11, I can work out the unit circle's equation, and also I can find the linear equation, and I can equalize them to find the intersection. So it is possible, okay, I'm not asking you to do it now, I just tell you it's possible to find the intersection between the angle line and the unit circle. And this point will be unique for every single angle, right? For a different angle, there will be intersection, and it's not going to change, it's just there. For this angle, it's just intersects here, and it's not going to change. For the 90-degree angle, it's going to be intersects here, and it's not changing. So what's the coordinates represent? You know the coordinates is with x value and y value, right? We have x value and y value for the coordinates. Okay, just let you know, the definition is not y, okay? It's more like the definition for sine is like that. The definition for sine and cosine is, we bracket this, okay? For this coordinates, the x coordinates is the cosine value of this angle, and the y value is the sine value of this angle. Okay, that's the definition for the sine and cosine. We draw the unit circle, we draw the angle line, and the intersection we have, the cosine value of the intersection, the cosine of that angle is the x value of the intersection. The y value represents the sine of that angle. Okay, so it's all the same. For example, I have this 330-degree angle. Okay, we have the intersection here. I will say the x value is the cosine 330 degrees and y value is the sine 330 degrees. And also, you know, as I explained, this point is something you can calculate. Well, or we can calculate in the calculator. It's something possible to find. In year 10, we're not requiring you to find point. Or also in VC, we're not requiring you to find this point. But all you need to know is, it's possible to find intersection. It's a known value. Like for this particular line and for this particular circle, we have an intersection. Well, by using CAS or by using some technology, by using algebra, I can work out the coordinates here. Why I find the coordinates here? The x coordinates represent the cosine of that angle, and this y value represents the sine of that angle. Also, this can be written as, okay, this is also possible to read as cosine negative 30 degrees and sine negative 30 degrees. Okay, why? Because I can say the angle is negative 30 from that direction. 330 degree and negative 30 degree, they represent the same thing. Okay, they represent the same thing. Why they represent the same thing? Because they have the same location. If they're at the same place, they are the same line, then all the sine and cosine value of, or even tan value of that angle will be exactly the same. Okay, you draw the line. If the line is at the same location, then it will be the same. Okay, then it will be the same. So, well, I can also say there's plus another 360 on this, or minus another 360 on that. So they all will be the same thing. Okay, they all will be the same thing. Also, I can write this 11 pi over 6. Okay, I can also write this 11 pi over 6. Okay, So that's the definition for sine and cosine. Okay, that's the definition for sine and cosine. Then I will introduce, let's talk about the tan for the next part. Okay, talk about the tangent. Okay, so for the tangent, we must remember this formula here. Okay, tangent is a formula. Tangent x is always the sine x divided by the cosine x. For example, tangent 30 degrees will be sine 30 divided by cosine 30. Okay, will be sine 30 divided by the cosine 30. Okay, what is sine? Sine is the y value of the coordinates. What is cosine? Cosine is the x value of the coordinates. So for that coordinates, you use the y value to divide by the x value. You will have the tan value. Okay, you will have the tan value. So that's how we find sine, cosine, and tangent. Okay, sine, cosine, and tangent. Okay, so that's the definition, the real definitions for sine, cosine, and tangent. It's not really something we only work in the right angle triangles. It's a more big picture about all the angles. Angles can be positive, infinitely large, can be negative, infinitely small. So how we work on those values, we only use one circle and different lines, okay? About 360 degrees, like those lines. So sine is the, okay, sine theta is the y value, cosine theta is the x value, and tangent theta is the y divided by x. Okay, so that's the three things you need to remember. That's the most important thing you need to remember for the unit circle and sine, cosine, tangent. That's the first thing we talk about today. The second thing we talk about here, well, is the ASTC. Well, instead of say ASTC, I like to say the cast, CAST. Okay, they are the same thing. It's just in different quadrants. Okay, there are 4 quadrants. Well, ASTC is in first, second, third, and fourth quadrant order. But it's hard to remember. I just say cast. Remember a letter. It starts from this quadrant, so it's C here, A here, S here, and T here. So what is it? I'll explain what is it. CAST. Cast. C means cosine. A means all. S means sine. And T means tangent. Okay? CST is sine, cosine, and tangent. The A means all. So everything. Sine, cosine, and tangent. So means all. Okay. This letter shows you that which is positive in that quadrant. Okay, which is positive in that quadrant. So give me any angle. Give me any angle. Just something, well, not 1,000 something. Give me something reasonable, like 180. Not on the axis. Not 90. 85. Yeah, 85. So 85 is something here. Okay, if you know 85 is not over 90, so it's something here. This angle is in the first quadrant. Okay, in the first quadrant. Sine, cosine, and tangent, they will all be positive because of that A. Okay, that's something 85. Give me something else, not in that quadrant. 230, so which quadrant is that? The third. So 230, 40 away from the 40 away, so it's approximately here. So 230. Okay, if we say that's 230, we can see only tangent is positive for this angle. Okay, only tangent 230 will be positive. Sine 230 and cosine 230 will be negative. Okay, so that's what the cast means. Okay, I'll explain. That's how we use it. Now I'll explain why it's like this. Okay, why it's like this. So remember, the unit circle is the intersection between the angle and intersection. Between the angle and the circle, the intersection gives you the sine, cosine, and tangent values. Let's think about angles in the first quadrant. Okay, in the first, second, third, and fourth quadrant. Okay, let's think about the x coordinates, y coordinates, and I'll leave the last one to talk about later. So think about the values for any coordinates in the first quadrant. Is the x and y positive or negative? In the first quadrant, the coordinates, they both positive, right? So it's positive and positive. Think about in the second quadrant, x and y, whether they are positive or negative. Y is positive and x is negative. How about in the third quadrant? Both negative, and in the fourth quadrant, positive and negative. Okay, remember, like, I don't know where they intersect, but the intersection for first quadrant, they'll only intersect in the first quadrant, right? Like somewhere in the first quadrant within the circle. So x represents the cosine theta and y represents the sine theta. If the angle is in the first quadrant, well, doesn't matter where they intersect, but the coordinates will definitely be positive and positive. So therefore, sine and cosine value, they will be both positive. And remember the tangent. Let's try some. Cosine theta is the x value. And tangent theta is y over x. Okay, it's y over x. So that's the cosine and sine tan. And okay, y over x is the tangent value. Okay, think about the first quadrant coordinates. Sine divided by cos, whether it will be positive or negative. Positive. How about in the second quadrant? Yeah, third quadrant? Yeah, negative divided by negative. And fourth quadrant? Negative. Okay, now let's have a look. In the first row, in the first quadrant, all three values, they are positive. So that's why we have the A here. For the second row, only the y value is positive. So we have the S here. For the third quadrant, only the tangent is positive. We have the T there. And for the fourth quadrant, only the cosine is positive. So we have the C there. So that's the cast. That's how we find the CAST. And that's why it will be positive or negative. Okay? So for particular quadrant. So just draw the angle line. After you draw the line, you see, oh, it's in the fourth quadrant. Well, I know definitely sine will be negative and cosine will be positive. Tan will be negative. So CAST. From the fourth quadrant, CAST in that order. Does that make sense? What we go through now? Like that's how we get the cast and what's the unit circle and how we get the sine, cosine, and tangent values. Okay, so that's the second thing we talk about. And the third thing we'll talk about today is a special angle. Okay, special angles. So what are special angles? Okay, what are special angles? Special angles is the sine, cosine, and tangent value will have exact form to represent. You know, like for example, I have my calculator on and I put sine pi on 7. Well, we know pi on 7 is 180 divided by 7 degrees, right? 180 divided by 7 degrees. I'm not going to change the radian form now, like I use the radian form. That is equivalent to 180 divided by 7 degrees. So I can press Control and Enter for that. or I press enter for that. Can you see it's either stay like this or give me a really infinite many numbers, like it's something I can't read. I either write the exact form like this, or I can write the decimals, like it's not recurring, and also I can't use exact values to represent it out, like I can't show it. So this is something it's not special, okay? It's not special. Most of the angles will have this character, this like common features like that. The value is not that easy to be exact, but there are some angles really nice. For example, I show you one. Sine pi. Okay, let's see what is it. It's a 0. Okay, sine pi is a 0. I can use exact form to represent it out, or I can use sine pi over 6. Okay, that's a half. So there are some angles really nice. Okay, some angles really nice. So now we're going to talk about what angles are going to be nice. Okay, nice values. So what values, what angles I can find by using what properties. So if we think about first group of special angles, they are the angles with multiple of 90 degrees, or say multiple of pi on 2. So 0, 90, 180, 270, 360, or going backwards, or negative 90, negative 180, negative 270, and negative 360. So the angle on the x-axis or y-axis, okay, the angle on the x-axis or y-axis will be the first group of special angles. Why they will be special angles? Let's have a look at the unit circle we sketch here. Can you tell me what's the intersection here, please? This intersection is the y-axis. Okay, repeat again, what's a unit circle? Unit circle is center at 0, 0 with a radius of 1. 0, 1. Okay. Remember what is the x is the cosine or the sine value? X. Cosine, and y is the sine value. So what angle is this one? 90, right? 90. So 0 is cosine 90 and 1 is sine 90. Okay, that's how we worked out why it's a special thing. Okay, so how about this point here? What's the coordinates here? That's the x-axis. 1, 0. So what the angle is this one? 0 or 360. So cosine 0 will be 1 and sine 0 will be 0. Okay, same thing with this side and this one. Okay, you can work out the 180 and 271. So can you use this fact to fill in this table for me, please? Okay, we have 0, 90, 180, and 270. That's the 4 points on the x-axis and y-axis. Can you show me what's the intersections and fill in this table? So for the 0 degree one, I know because I use the unit circle here, this point is 1, 0. So 1 must be the cosine value and 0 must be the sine value. And tangent is sine divided by cos. So I have a 0 here. So tan 0 will be 0 as well. So sine divided by cos gives me the tangent. Okay, can you use the same idea to work on the other 9 boxes for me, please? So we will talk about that later. We will talk about this later. I just say why the sign that is important. We haven't moved it. Okay, for the 90, I have intersection here. The intersection is 0, 1. Okay, what's sine 90? Sine 90 is 1. Cosine 90? Okay, how about 10? What divided by what give you 10? Y divided by x, right? So it's 1 divided by what? Okay. What's 1 divided by 0? Is that 0? Undefined. I see over half of the class write a 0 here. It's not a 0, right? 1 divided by 0 is undefined. You can't have 0 as denominator. So what that means is tan 90 is not exist. Okay, we don't have tangent 90. So at that position, well, not only tan 90, well, tan 90 plus 360 will not be exist as well because it's the same position. So all the angle on the y-axis will have no tangent values. Okay, no tangent values. Okay, how about 180? The intersection here is -1, 0. So what's sine 180? Sine 180? 0. Cosine 180? -1 and 10? 0. If 0 divided by -1 is fine. It's a 0. 0 can be the numerator, not the denominator. So that's a 0, no problem. How about 270? So 0, -1. So sine is -1, cosine is 0, and 10 is undefined. Good. Okay, that's how we find all the sine special, cosine special, and tan special. The special group is when is the multiple of 90 degrees. When is the multiple of 90 degrees. You can see 0 is the 0 times, 90 is the 1 time, 90 is the 2 times, was the multiple of 90 degrees. Okay. And okay, we do an exercise here. Can you just find somewhere to work out what sine 5 pi over 2 is? Okay, can you work out what is sine 5 pi over 2? Okay, 5 pi over 2, you need to work out where is it. Okay, it's the radian form. Okay, so it's the C. So you need to find where is it. Is this special? How can we work that out? 5 pi over 2. Okay, sine 5 pi over 2. Where is it? And what's the intersection between that line and the unit circle? Do we take the y value or do we take the negative x value? Anyone find the answer? Where is it? I don't really need y, positive, negative. This way or this way? That way, positive. So it's the same as 90 degrees. Okay, that will be the line. Can you see? Well, why is there? What's 5 pi over 2? That's 2 pi plus pi over 2. Can you see that? It's a 4 pi plus pi, like 4 pi over 2 plus pi on 2 is 2 pi and a bit. Why I get the 2 pi out? Because when you turn 2 pi, it's a complete cycle. And then you further go in another 90 degree. Okay, further going another 90 degree. That's easier to convert into degree first. And then find where is it. Okay, when they give you pi, you use pi. Do not try to convert it all the time. You try to think about the position. You know pi on 2 is a 90, it will be there. And you know 2 pi will complete a full cycle and then keep going for another pi on 2. So that's why it's at the positive position. Okay, it will be the positive position. Better not to, because it slows down. It slows you down a lot. Well, you need to get used to the radian form because everything later will be all in radian form in year 11. It's not going to be degree at all. So it's all radian form. So when you convert, you times 180, it takes a long time to do it. And then you need further counting how many 360s are there. Like it's easier to use pi if you can see where are they. Okay, what's the intersection here? What's the intersection here? 0, 1. Okay, for the sine pi, 5 pi over 2, what that equals to then? Huh? Sine. What is sine? Y. What is y? 1. Good. That's just 1. Okay, the y value is the sine 5 pi over 2. So 5 pi over 2 is there. Make a 0, y intersection with the unit circle, and we take the y value to be the sine value. The cosine is what? 0. Good. Okay, we get it. We get it. So that sine is the y and cosine is the x. And what is the tangent? And define. So y divided by x and define. Good. Okay, that's the first type of special angles with only 0 and 1 or negative 1. Okay, 0, 1 and negative 1 is all the angles on the axis. Okay, all the angles on the axis. Alright, I'm not going to continue with the second type. But what I will do here is I give you 2 triangles here. Okay, 2 triangles here. If I tell you, this is something homework I want you to think about. I give you 2 triangles here. This is a 45-degree right angle triangle. Okay, that's a right angle triangle with 45 degrees here. And 45 degrees here. And this one is an isosceles triangle, equilateral triangle with all 60 degrees here. Okay, all 60 degrees here. Okay, for the 60-degree angle, what I want to do further is I want to draw the height. With a height here. Okay, now I give you some value. I give you some value. If I said this is 1, this is 1, what's the hypotenuse will be? Root 2. 1 plus 1, and then we square root that is root 2. Okay, if I give you this one is 2, this one is 2, what's the length here? Here. 1. What's the height? What's the height? How we calculate that? Pythagoras, 2 square minus 1 square, which is 3, and we take a square root. That's a root 3. Okay, that's a root 3. Okay, I want you to find all the sine 30, sine, cosine, tangent for 30 degrees, 45 degrees, and 60 degrees by using those two triangles. For example, give you a hint. If I want to do a sine 60, that will be the root 3 over 2. Can you see that? That's the root 3 and that's the 2. The opposite over the hypotenuse. Okay, I can also do the cosine 60 and I can do tangent 60, this over that. So I just want you to use this triangle and this triangle here to write 9 values. Okay, sine, cosine, tangent of 30, 45, and 60 degrees. And complete the above table for me. Okay, complete the above table. So the above table is special angle as well. You can see the sine 60 give you root 3 over 2. It's a quite nice value here. So I want you to use the rest of the time to complete the above table, and we'll start from this point next lesson.